YouTube, we back. Yeah, I've been out for a while, but we back. Where was I? Let's just say I got some important stuff. I was doing some really important stuff. Let's just keep it that way, okay? Just keep it that way. You know who it is? JOHHABRAHAM. We're back with the chemistry. We're gonna be doing chemistry. No, not chemistry. Whoa, physics. We're gonna be doing physics. G is equal to oh. G is equal to m1 by m2 by m1 into m2 by. Not gonna lie, I forgot that formula. But okay, it's okay, it's okay. We're back with physics, and god damn it, my tablet and my tablet is not having enough battery. I gotta charge them. So, let me charge them fast. Dude, why are you so slow? I don't know. So this time we're gonna start with we're gonna start from the back. We're gonna start from assignment number 12. The exam is tomorrow. Yeah, we don't got too much time. No, I don't got too much time. Who's we? It's me. Oh, I was like, oh, is the mic muted? Fortunately, no. Shut. Forget about your boy, Brandon. Meet me at the hotel room. Bet about your boy. Meet me at the hotel room. How long can I study? Realistically, now this is my plan, okay? This is how I plan how it's gonna go. I'm gonna study for 1 hour. I'm gonna go sleep. I'm gonna wake up early. Early morning. And minimum 5 hours. If I need to get 5 hours, let's say 11, I should be up at if I'm up at 5, I should get 5 hours. 5 hours. Yep. Now it's time to speed. I am speed. Situations are really bad. My phone is not working now because I haven't paid my phone bill. I haven't paid my rent. I haven't paid my insurance. No. Why am I such a failure? Why am I such a bum? Why would I be like this? Why should I make changes? So, the first question is we got two objects of two masses of two directions, and to mass at time t, it collides perfectly inelastically at the origin. Okay, the point of collision is at origin. I don't get this one. Okay. Now, what is the distance between two particles 1 second before the collision? So it's going to be t minus 1, right? Why is it t equals -1? Oh, at collision, time equals 0. Why? Wait, I thought the position of collision is at origin at time t. How is the collision at time 0? I didn't get that part. Also, the R1 equal to R2. What? Oh. What does this mean? Because from what I understood, I don't know what is R actually. I should set a timer for 30 minutes. Just what? Wow, you wrote that much? RT position vector tells you where the particle is at in the space relative to the chosen origin. R particle is 2 meter in x. So R1T. Why is the collision at t equals to 0? This is by choice, not law by physics. In mechanics, you're free to choose what t equals 0. Collision happens at t equals 0. That means we set our clock so that time 0 is an instant they collide. Time before collision are negative, time before after collision are positive. This is done because it makes the equation simpler. Why is the collision point the origin? Okay. Okay. So 1 second before the collision. Okay, now I get that the time t is 1 second for the collision, which is -1. So how do I proceed? How do I apply that -1 to the corresponding vectors? Vectors of the masses are for constant velocity motion, RT equals R0 plus VT. From the problem, both R0 is okay, so the equation simplifies to so you just put -1, okay. Distance between the particle comes from the difference in position vector. Take the magnitude to get the distance. Okay. Something's firing up. What were the kinetic energies of the two particles before the collision? How do I know this? Also, we don't confused on at what time or the K is same until the collision. Good question. This confusion is common, so I'll be very explicit. Good question. Very good question. Key idea first. This removes 90% of the confusion. Before the collision, each particle has a constant velocity. The speed is constant. Kinetic energy is constant. It does not depend on time. As long as the collision, this has not happened yet. Okay. So, okay. So for the particle of mass m and speed v, kinetic energy is half mv squared, half mv squared, half mv squared, half mv squared, half gt squared, half mv squared. V is the magnitude of the velocity vector. Magnitude of velocity vector is the same thing as this, just the magnitude of a vector. Okay. So what were the kinetic energies of the two particles? So you just apply that, I'm guessing, right? Yep. What's the velocity of the combined particles after collision? What's the velocity of the combined particles? What's the velocity of the combined particles after collision? Okay. Do we just I forgot the term. What is it called? Magnitude. Find the magnitude. Or is there a bit more complex equation coming up. There's more to it. This is where momentum conservation comes in. You do not take magnitude and add them. That would be wrong. This is where perfectly inelastic collision. Inelastic collision. Inelastic collision. What is elastic collision? Linear momentum is conserved. No external forces. P before, P after is the same. Momentum equals mass into velocity vector. So we got P2. P total equals add the momentums. Okay, so it's like divide by total mass. Ah, P total. P total by mass. Okay. So the after collision, velocity of a combined particle after collision is what? Is what? Inelastic collision. Is the sum individuals before collision almost correct. And when we but yeah, okay, that's the vector momentum conservation. When you got it right, you divide it by total mass. The magnitude of the final answer would be velocity, not quite. The result of the formula is already the velocity vector. The velocity is the vector itself. The magnitude gives the speed, not velocity. That makes sense. What fraction of the kinetic energy was converted into internal energy? I don't know. Okay, what is the next question? A bullet of mass 10 grams is fired at the wooden block of mass 1 kilograms. The wooden block is attached to a spring. God damn it. Speed, scalar quantity. That's the word. Scalar quantity. Vector. What is vector? Magnitude and direction. Has magnitude only. So time would be a scalar quantity, right? Yeah, that makes sense. Exactly. Okay. Shut up. What fraction of the kinetic energy is converted into internal energy? After perfect collision, the common velocity of the two particles. 0 to 2. Okay. It's interesting that these people like write it like this, but back in India, I used to like write it like this. Anyways, answers are correct. Don't matter, boy. Okay, let's finish your perfectly inelastic collision problem step by step. Total kinetic energy before collision from earlier, K1, yeah, K2, K before. Some kinetic energy after collision combined means velocity after collision, magnitude, speed. Kinetic energy after collision. Half total mass divided by multiplied by, okay, so that's 20 joules. Is it same? No. Kinetic energy converted to internal energy. 30 joules, fraction of kinetic energy converted. It's 0.6. 60% of kinetic energy was converted into internal energy. Why though? Heat deformation sound. Okay. Bullet of mass 10 grams is fired at a wooden block of mass 1 kilogram. The wooden block is attached to a spring. A spring of spring constant D equals 400 newtons per meter. The projectile gets stuck in the wooden block. A maximum elongation of the spring of 10 centimeters is observed. Elongation or constraint. What is the speed of the wooden block immediately after the collision? What speed does the bullet hit the wooden block? And I'm confused. Spring elongation part, which the spring should compress, right? I see where's the confusion. Let's go carefully step by step, understand the problem. We have bullet, M equals 0.01, wooden block, 1 kilogram, spring constant, maximum spring elongation. I don't get the spring elongation if, like, whereas speed of the block immediately after collision. Speed of the bullet before the impact, visualizing the spring. The spring is attached to a block. After the bullet embeds the block, moves and stretches the spring. No. No, here, core to the diagram, the order of the things are bullet, block, spring, the wall in which the spring is attached. Also, this might just be a mistake, but does that matter in finding the answer? Got it. Thanks for clarifying. The order makes sense. So the spring between the block is no, for calculating the block velocity immediately after the collision and bullet speed, it doesn't matter. But why? Because these calculations have been solely on the momentum conservation during the bullet block collision. Before the spring comes into play, energy conservation to find the speed from the block, find the speed from spring elongation after collision. Again, it's not spring elongation. Timeline of events. Okay. Now, how do I start with such a question? Before collision, bullet moves with the velocity one-dimensional problem. After collision, bullet and wooden block system moves with the velocity v, and then compressed the spring which stops at x max. During this compression phase, mechanical energy is conserved. Look at the problem. It separates its distinct. List the known quantities. Use energy conservation for spring. At maximum spring compression, stretch. Half kx max. Kx square max. Solve for V block plus bullet. So wait, maximum spring compression slash stretch. Half sum of the block and equals the velocity of the block, or the new block plus bullet, equals half k x square max. Now what is x max? Maximum compression or stretch. Okay, that's the new term. What is k? K is the spring constant. Spring constant. KKO official. Hello. You're studying biochem, right? Fortunately, yeah. And I got my exam tomorrow. Bro, ain't gonna lie, I'm pretty scared. Ain't gonna lie. But yeah. Also, I think it's your first time coming up here, right? I appreciate you for checking out the stream. Also, again, I said two alsos. There's a slight latency issue coming up. There's a slight latency issue, but don't mind. What's the grade you're doing? What's the grade? Like right now it's like first semester. Like I'm in college, and this is like first semester physics. It's like basic physics, but still, I failed this exam once, not once, two times. So great. Did that answer the question? Because I don't exactly know which grade it would be. It's like a first semester physics. Okay. So it's the energy conservation of spring. It's immediately after collision, but before the spring slows the block. What is the speed of the wooden block immediately after collision? At what speed does the bullet hit the wooden block? At what speed does the bullet... Whoa, we're not even given the speed of the bullet? How do you find that though? Okay, we got a maximum elongation of the spring, 10 centimeters. That's x squared, right? Yeah. Whoa. Use the momentum conservation. Yeah, I'm in seventh grade physics, and for chemistry, I think sixth or seventh grade. Okay, you're in school. I believe you've seen some of these, right? No, I don't think so. But at least you should see some of these things in the future or right now, because this is basic physics. It's not the high level, not the physics major type of physics. Mhm. Optional check spring. So we get the collision velocity. I'm homeschooled, but I don't know how to solve. I don't know how to solve what you're doing, but I agree. You should at least have. You should have the initial speed given. Hey, that's actually a good start. Not the cases. Initial speed would be zero if it's like free fall or something. And there's an equation like uh, s is equal to ut plus half at square, right? You should know that equation. That's like the basic equation for velocity. It's type sheet. Your homeschool. That's it's crazy. Well, was that a personal opinion, or how do you enjoy homeschooling? Write down what we know. Yeah, 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 yeah. Use the momentum conservation. MV bullet plus MV block initial equals M plus PV after. V block initial is 0. Ah. So the sum. So it's like a. The KE. No part is momentum conservation. Okay, can you give momentum. Right now, I'm studying finance. Finance on seventh grade, but I always like seeing other people study. I'm mostly self taught, heavily relying on Google Docs, and WPS Office has saved me, not gonna lie. WPS, I know WPS Office is an app for like Excel, Google Docs, to do lists, things like that. What, you're studying finance, but you're in seventh grade. Interesting. I guess that's like the good parts of homeschooling. You get to learn a lot. Hmm. But what do you feel about not going to school or in, interacting with other kids? I mean, what? Don't worry about my chat. Momentum conservation scenario 2. Ice skaters push off each other on frictionless ice. Okay. Kinetic energy conservation 2. Billiard balls collide perfectly elastically. Potential energy. Ball drop from height h, ignore 8. So that would be momentum conservation from what the GPT say. This would be kinetic energy conservation. And momentum after. I don't know how real school works. I've been in school up until second grade, and after that, I have mostly been relying on devices to help me learn. I'm 10, by the way. If you don't know, and no, I'm not lying, okay? You're learning finance at the age of 10? Good for you, bro. Or sister, good for you. 10? Oh. Not gonna lie, it gives me hope. Damn. The younger generation are fucking. Solve for skater B. V2 equals minus M1. 30 minutes. Should I take push-ups? No, it's night. I should not take push-ups. I honestly thought finance is a normal thing to learn at 10, bro. Yeah, it is normal. Good for you, brother. Good for you. I'm guessing you are interested in finance, right? What was I doing at 10? 10. Yep. I know exactly what I was into when I was 10. Kinetic energy conservation. Two billboard balls collide perfectly elastically. M1 V1 is equal to M2 V2, M1 V1 is equal to half M1 V1 square, okay. Okay. So, homeschooling, do you have an online tutor, like online school? Or does your parents tell you what to learn? How to start this type of question. Identify what happens first. Bullet hits the block perfectly in elastic collision. Bullet sticks immediately after the block. Plus bullet move forward. Spring stretches to maximum elongation. Read properly, bro. Come on. Spring stretches to maximum elongation to find the bullet speed. We only care about the collision, not the spring yet. We only care about this collision, not the spring yet. Okay. Write down what you know about collision. Block plus bullet speed after collision. Before, after, right? Yeah, I think I'm gonna be an investor, both. I will do trading and investing, but mostly investing. Trading will be for quick money, and I think I'll invest slash trade in Nvidia, Apple, and Amazon. The three giants at the age of 10? Uh, don't get me wrong, but whose money are you investing? Your parents. Do they know? Oh man, the internet is fun, not gonna lie. I don't have an online school. I tell myself what to learn, with ChatGPT being my version of a tutor. ChatGPT being a tutor for a 10-year-old. Hmm. I mean, I can't see that happening. Not gonna lie, I can't see that being happening. But do I feel good? What do you feel, bro? Do you think ChatGPT is teaching you enough? Like, or do you think it's a really good teacher? I don't even use real money to invest. I actually use trading slash investing sims to hone my skills so there's no consequences. Okay. Sims. That's the first. It kind of makes sense, but it's the first time I'm hearing. You could use fake money or something that replicates investing and track how it's working. That's good. Okay, that's good. That's cool, bro. But what do you see from this? I'm gonna go eat right now, yo. Respect. Appreciate you for checking out the stream. Identify what happens first. Bullet hits the block. Wait. Maximum spring elongation occurs when kinetic energy of the block bullet converts fully into spring potential energy. So maximum spring occurs when the kinetic energy of the block plus bullet converts into fully spring potential energy. So it's conversion of kinetic energy to potential energy. Where is momentum conservation? Block initially at rest. Bullet plus block speed after collision. V after. We found that using the momentum conservation law, right? Yep. Mm, MV. MV. I seriously set a timer for 30 minutes. Just a minute. Let me send this. Just a minute. Just a minute. Just a minute. Okay. Add, manage, done. Next, go.
Last week on More, Part 8.
Just a minute. Come on, come on, come on. Come on, come on. 97 subs. Let's go. V square after. Why? Late spring elongation to the velocity after collision. Why do we need the V? Apply momentum conservation. MV bullet plus MV block initial plus, okay. We get the value for V after. And we calculate V of the bullet from that. This one would be 0, okay. To 109 meter per second. Is it correct though? Nuh-uh. This is 0, right? 35 meter per second. Why though? That's not the answer. V is equal to M1 plus M2 by What is the V after? Uh, oh, it's not in a copy of a form. Not even close. This is how another solution for finding the velocity of the block right after the bullet hits. Mhm. Just a minute. Just exactly the solution is doing the same area as the bullet block spring problem, but the expression is slightly different way. Instead of immediately using the spring energy formula, it used work energy principle. 22 minutes. What's happening in that solution? Completely inelastic solution, cards stick together. Or in a bullet block problem, bullet embedded in block after the collision, the combined object moves with velocity v. Okay, okay. Cards stick together. Friction spring does the work. In the car example, friction converts energy. Work energy principle. Kinetic energy after collision is equal to energy absorbed by friction or spring for cars. No, stop for the cars. Bullet blocks. So half total mass by I think this is the mass of the velocity of the bullet block. That's what we did the right before. Is that what we did? Momentum conservation. Okay. So you could do both momentum or kinetic energy conservation. Back. Hey, you just ate that fast? Being 10 years old? Respect. Momentum conservation. I have a bullet via bullet plus exactly. There's an important nuance always used for collision, especially in elastic collisions. Gives you the immediate post collision velocity. Works even if the kinetic energy is not conserved. Kinetic energy, work energy conservation used after collision to relate motion to spring compression, friction, or distance traveled formula. Solves for V after. Okay. I had 3 pizza slice. Munib makes. Yo, what is this? Guess what? I have a physics exam coming up tomorrow, and I was just looking into the portions. Appreciate the Munib makes for checking out the stream. What grade is this? This is college, bro. This ain't no grade. I mean, these are just basic physics. This is not like high level physics. So KO official, you just had 3 slices. Is that enough though? 40%. Because there's a slight difference. That looks so scary. Laugh out loud. This should not be scary. If you look into this, it's not that scary if you think about it. Without using frictional energy, determine the time to rest after collision and insert it into the stopping distance. That's a different way to do it. I hate that they don't say what these units are or terms are. Low level physics. This looks like ancient Egyptian Hyro. Yo, did you write that, bro? Hygro. Come on, I can read that. Hieroglyph. Hieroglyphs. Did I just swallow the G? Hieroglyph. Hieroglyphics. Bro, like someone threw up math equations and said there's new equations for blah 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 blah. I understand where this is coming from, but trust me, bro, it's not that deep. It ain't that deep. You know what? I think I'm done with that one. Let me look the next one. I gotta redo all of them, but before that, let me up. Assignment number 11 with the solutions. The biggest problem with physics is when you look at the solution, you'll be like, oh, I know this. It's easy. It was never easy, bro. I need to do this, but before that, let me look up how the solutions are. Do you use Apple or Windows? I wouldn't say unfortunately, but Apple right now. When I get enough money, when I get a part-time job, I'm gonna go for a Linux machine. I know it's really hard to use Linux, but still, I'm gonna be skipping Windows because I have used Windows. I have used Windows before. It's not the best. Comprehension question. What is work done by friction force on a body sliding down an inclined plane? What is the work done by friction force on a body sliding down an inclined plane? I usually use Windows 11 Pro. Mm-hmm. Windows user. Let's go. I actually planned on right now I'm using a laptop from Apple. I actually if I bought a Windows laptop, I could have played a lot of video games. But I bought the Apple one because of battery. This thing is has really good battery life. The newer ARM-based Windows laptop, they do also have good battery life, but during that time when I bought this laptop, there was only normal Windows laptop, no ARM-based laptops. What is work done by friction force on a body sliding down? What do you mean? What is work done by? It's in the opposite direction. I know that one. What is work done? I am just so confused by that question. What is work done by friction force on a body? What is work done by? What is work done by friction force on a body? What do you mean by what is work done? I'm pretty confused on that question. I know the direction. Why are you giving me scenarios? Friction always does negative work. If you want, I can. Oh, wait, what's the answer though? Do we got an answer? No. We don't have an answer for comprehension question. KK official, do you use a laptop or a PC? Desktop. I'm guessing a desktop. Because Windows 11 Pro, most likely a desktop. I need to get the desktop. I need to get my money up. I need to get my money up. If you no, so the keywords answer or the main keywords are friction, exactly. That's how it's gonna start. Yes, exactly. Energy lost by friction equals work done by friction. What is work done by friction force? It's a negative. What is work done by friction force? It's a force acting negative. Force acting opposite to the direction of motion. Work done by friction is negative. Friction removes kinetic energy from the body. Okay, okay. Oh. How is energy conservation principle formulated to include the work done by friction force? What? How is energy conservation principle formulated to include the work done by friction force? How how is energy conservation principle formulated to include the work done by friction force? How? I don't know. What's the formula for that? I'm guessing it's normal force minus the frictional force. Do you play any video games? KK official. Code in HTML. Standard energy conservation for a body moving under conservation forces only, like gravity, springs. Total mechanical energy equals K plus B constant half. Including work done by friction, non-conservative force. When a non-conservative force like friction do the work, the mechanical energy changes. The principle becomes work done by non-conservative force, or equivalently. Yeah, so you just subtract the work done by friction, right? You just subtract the absolute value of the work done by friction. Here S equals distance along the incline. Key idea: friction is a non-conservative force. It reduces mechanical energy. It includes as a negative work in the energy equations. The rest of the conservation principle stays the same. Just adjust for the energy lost. Okay. Whoa. I apologize, KK official. YouTube is not showing your chat. I had to use OBS right now. You said a lot, bro. Just because my computer came pre-installed on it, I'm too lazy to install Linux or Apple's. Okay, makes sense. Makes sense. That's a valid point. I think the formula for work is like W equals force into acceleration. Yep, that does that. There's a formula for like that. You just see the force and then acceleration, and that's it. Yeah, that's basically it. A laptop. Oh, interesting. Bro, isn't this physics and or something? I don't see how this is bio or chem. Like, where's the molecular structure or mitochondria? Is the power of this powerhouse of the cell stuff? Well, guess what? I still haven't touched biology yet. I'm still on my chemistry era. Like my first year is biology, second year first year is chemistry, second year is biology. So right now I'm still on my first year. It's chemistry. Next semester I'm having organic chemistry coming up. I just passed the general chemistry. So first semester they do have math and physics, a little bit of math and physics, because that's gonna come up eventually. Trust me, bro, that's gonna come up eventually. And yeah, the more I go into studies, the more I get to learn biology. I still haven't touched biology. No, I don't usually play video games unless if they hone my cognitive skills or physical ones. Damn! If something doesn't benefit me, like as in physically or cognitively, I don't engage with it. Interesting. Uh, I kinda agree to that, but I used to play video games. I used to play type of video game. It's like have you heard about Soulsborne video games? Those type of video games are pretty. I wouldn't say really hard, but they're pretty hard. And for me, those type of video games, it kind of works in this way. It's like I have to keep fighting until I win. I have to keep doing it until I win. So I think that did help me mentally. But hey, I'm not saying you should play video games, okay? If you don't feel like playing video games, that's good. What happened with YouTube? It's not showing me the chat. I mean, I do still play video games. I don't know, they just aren't interesting to me. Valid. It's completely understandable, bro. Okay, now it's coming up. When I started refreshing, it started coming up. Yep, so biology, I still have to learn a lot. The only thing I learned something that's even related to biology is genetics, and it was introduction to genetics. Uh, so not that much. But hey, tomorrow physics exam. I gotta pass. I gotta pass. Including the work done by friction, non-conservative, 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 conservative. When non-conservative force like friction do work, the total mechanical energy changes. The principle changes. The principle becomes. I read this one. So it's basically just the sum conserved minus the work slash energy lost to friction Exactly, that's the simplest way to think about it. 30 minutes? No way, 30 minutes. It's 10 p.m. I don't really study bio. I used to, but not anymore since I want to get into MIT. And yes, I think there's some bio, but I want to learn physics and chemistry mainly. MIT. I heard about this university. Massachusetts. Cambridge. Hmm. Bro, you're 10 and you already know which university you have to go? That's cool. Kurama Crafter. Hello. Hey, Kurama Crafter, I appreciate you for checking out the stream. Also, I want to get a major in computer science and a degree in math and be good at physics and chemistry. Hmm. I mean, if you start learning chemistry, uh, it is kind of related to biology, or it's the other way. Biology is related to chemistry, but the biology is so complex that it needs its own, it needs its own. It stays as its own subject. It works based on physics and chemistry, laws of physics and chemistry. Mechanical energy equals mechanical energy minus energy lost to friction. Okay. A body is required to move from point A to point B through two different routes. Both routes involve inclined planes with consistent coefficient of sliding friction u equals zero point 0.2. Nice. Plus, I still wish you the best luck, bro. I just did my exam today. It was a bit stressing, but I passed. Hell yeah. Hell yeah. I'ma go, guys. My timer up for studying. Hope to see your stream tomorrow. I appreciate you for checking out the stream, bro. That was crazy. So how? Yeah, you had the 5 modules, right? All subjects together. Kuruma Crafter. Damn. You get to know the results that day itself. Determine the net acceleration of the body. Yup. Was it oral exam or written exam? I'm guessing written. But if it's written, it's gonna take time, right? It's oral. Because it's multiple choice questions. Oh, okay. Makes sense. How many questions were there for each subjects? Determine the net acceleration of the body on route A. Compute the time taken to travel down route A. Fuck. I can't simply give this question to GPT. Okay, okay. I have to do some small math. The 8 square 64 plus 3 square 9 73. Root of 73 8.54. Oh, bro, I need to. There was 26 questions. I mean that is crazy. You had to answer 5 different subjects one day. If you don't mind me asking, where do you study, bro? Which country? Because it's pretty interesting, the syllabus or the way they do the exam. And I have on Monday math part 1, and then I will have part 2 later, and part 3 too. Okay. So you just mm. So it's not over. Okay. You still got exams on Monday. So this weekend is going to be studying, bruh, I guess. Okay, it's 10 p.m. right now. I have to decide. Yeah, I still have more. Okay. Hey, bro. It's all good. It's better to learn. It is always better to learn. Mm. Yeah, of course. This week I'm gonna study a lot. Plus the exams are in 1 week till the end. So the whole next week is gonna be exam. How many subjects are left? I thought all the subjects would be over in one day. So you have math on Monday. How are others looking? 16 plus 9 5. No, AC, come on. My brain is slowing down. I can feel it. I can feel it. Let's carefully set this up so we can compare route A, route B using energy consideration, including the friction. Identify the distance along the incline of friction work. Route A is hypotenuse of time. I just need to know if you get the right answer, though. Looks like you didn't, bro. Oh, you though? Let's see. Let's see ChatGPT is intelligent or not. I don't think so. I don't think it's good enough to find this. Whoa, it is. It is. I'm sure one question from this is coming up. Yeah, math, Monday part 1, then Thursday chemistry, Wednesday Spanish, Thursday math part 2, oh, and Friday programming. Okay. That's a pretty good schedule, not gonna lie. You got programming, you got Spanish, your chemistry. Plus, you have 10 p.m. to you. Me too. I got 10 p.m. Where do you live, bro? I live in Morocco. I have a friend who's in Morocco. I'm in Austria right now. It's a country, small country near Germany. Österreich, you could say. You were in Morocco. Let's go. Respect Morocco. Plus, you have 10 p.m. Okay. So that makes sense. Oh, Morocco, Austria, kind of same timeline or time zone. Interesting. Mm-hmm. Okay, it's sharing the same sharing the same time zone during winters, but when it gets to summer, it starts to differ. So there's gonna be a 1 hour difference. Uh-huh. Okay. That's cool. Hey, that's cool. Which part of, I don't know if it's too specific, it's north, south, because I heard that there's two Moroccos, north and south. I don't know if it doesn't do much. Not gonna lie, I can't focus right now. It's better I go to sleep. I wake up early. But before I go to sleep, I need to send a message. Yo. How do I send a reply to these people? Email drafting. No, I'll use this one. Yeah, same time plus. That's so cool. That is pretty cool. Not gonna lie. Well, not gonna lie. I'm about to end the stream because, yo, I gotta wake up early tomorrow. I need to focus. But before that, let me send an email. Kurama Crafter, are you? I'm guessing you're in school, right? And you don't have the offline school. Yeah, I don't think you're in offline school. Online school. But I did see something in your account. You do paper craft. That's interesting. Do you still do it, or was it? Sorry, bro. Got to leave. Because, bro, I haven't go to sleep. I have a big day tomorrow. Good luck. Wish you the best on the exam. Best luck. I'm gonna always check your stream. Yes, I'm in school. Hey, yo. I appreciate you for checking out the stream and good luck on the exam. You got this, bro. Got this. It's it's not, I mean, don't take this in a bad way, but it's not about the exam, it's about the knowledge. It's about knowing. Yes, I'm gonna try to continue after the exam. Yeah, that's a good hobby to have. Not gonna lie. Thank you, bro. Thank you, bro. You're the best. Appreciate it, Dane. Appreciate it. Okay. Okay. Yeah, September. September, yeah. Goodbye, bro. Good night. Good night to you. Good night to you too, my friend. Stay strong. I'm also gonna end the stream within maybe like 10 minutes. Uh, what was I writing for the email? So now. Ist Habanov. Den Habanov, what is April. April. Mhm. Steigen wäre ein Start. Okay, I'm gonna end this stream because I gotta wake up tomorrow in the morning. And we're gonna be better. We're gonna be smarter. We're gonna be stronger. That was cringe. Nah, fuck cringe. Fuck cringe. Who gives a shit? Peace out, YouTube. Peace out, Twitch.